ಆತ್ಮೀಯ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರೇ, ಇಂದಿನ ವಿಕಸನ ಸಂಚಿಕೆಗೆ ತಮಗೆಲ್ಲರಿಗೂ ಸ್ವಾಗತ. ಇಂದಿನ ಸಂಚಿಕೆಯಲ್ಲಿ ನಾವು ಎರಡು ಸೆಕೆಂಡ್ PU ಟಾಪಿಕ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಒಂದು ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿ, ಇನ್ನೊಂದು D&F ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್. ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಲೆಟ್ ಅಸ್ ಸಿ ದ ಫಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿ. ಸರ್ಫೇಸ್ ಕೆಮಿಸ್ಟ್ರಿಯಲ್ಲಿ ಮೊದಲನೇ ಕಾನ್ಸೆಪ್ಟ್ ನೋಡೋಣ, ದಟ್ ಈಸ್ ಅಡ್ಸಾರ್ಪ್ಷನ್. ಅಡ್ಸಾರ್ಪ್ಷನ್ ಅಂದರೆ ಅಕ್ಯುಮುಲೇಷನ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಫ್ ಲಿಕ್ವಿಡ್ ಆರ್ ಗ್ಯಾಸ್ ಆನ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ಎ ಸಾಲಿಡ್. ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ಸು ಸಾಲಿಡ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಅಡ್ಸಾರ್ಬ್ ಆಗ್ತಾವೋ ಅವನ್ನು ಅಡ್ಸಾರ್ಬೇಟ್ ಅಂತ ಕರಿತೀವಿ. ಆ್ಯಂಡ್ ದ ಸಾಲಿಡ್ ಸರ್ಫೇಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಅಡ್ಸಾರ್ಬೆಂಟ್. ನಿಮ್ಗೆ ಗೊತ್ತಿರಲಿ, ಈ ಅಡ್ಸಾರ್ಪ್ಷನಲ್ಲಿ ದೇರ್ ಆರ್ ಟೂ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್. ಒನ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಫಿಸಿಕಲ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆ್ಯಂಡ್ ದ ಅದರ್ ಒನ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ chemical adsorption. First one is chemical and second one is physical. So physical adsorption go chemical adsorption difference ಏನು ಅಂದರೆ, physical adsorption ಅಲ್ಲಿ the particles or molecules will be held on the surface of adsorbent by means of weak van der Waals force of attraction ಅಥವಾ weak intermolecular force of attraction. Intermolecular force of attraction. Intermolecular forces. Whereas in chemical adsorption, the particles or molecules are held on the surface of adsorbent by means of chemical bonds or chemical forces. ಎರಡನೇ ಮೇಜರ್ ಡಿಫರೆನ್ಸ್ ಏನು ಅಂದರೆ, ಫಿಸಿಕಲ್ ಅಡ್ಸಾರ್ಪ್ಷನಲ್ಲಿ ದ ಪ್ರೋಸೆಸ್ ಇಸ್ ರಿವರ್ಸಿಬಲ್. Whereas chemisorptionನಲ್ಲಿ ಪ್ರೋಸೆಸ್ ಇಸ್ irreversible. And the third difference between these two is the enthalpy of adsorption. Physisorption alli the enthalpy change is around 20 to 40 kilojoules only. Very small amount of heat is evolved when adsorbate molecules sit on the surface of adsorbent. Whereas in chemisorption, it ranges between 80 and above 80 to 240 kilojoules per mole of gas. And next difference is, in physical adsorption, you can achieve multimolecular layer. That means it can form more than one layer of adsorption. ಆದರೆ chemisorptionally it is almost unilayer or the unimolecular layer. ಎಫೆಕ್ಟ್ ಆಫ್ ಟೆಂಪ್ರೇಚರ್ ನೋಡೋದಾದರೆ, ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ದಂಗೆಲ್ಲ ಇನ್ಕ್ರೀಸ್ ಇನ್ ಟೆಂಪ್ರೇಚರ್ ಡಿಕ್ರೀಸಸ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆರ್ ರೇಟ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಫಿಸಿಸಾರ್ಪ್ಷನ್. ಆದರೆ ಕೆಮಿಸಾರ್ಪ್ಷನಲ್ಲಿ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ದಂಗೆಲ್ಲ ಅಡ್ಸಾರ್ಪ್ಷನ್ ರೇಟು ಸ್ವಲ್ಪ ಹೊತ್ತು ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಟಿಲ್ ಎ ಮಾನೋಲೇಯರ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಟೇಕನ್ ಪ್ಲೇಸ್. ಆಮೇಲೆ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಮತ್ತೆ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಕಾನ್ಸೆಪ್ಟ್ ಕ್ಲಿಯರ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಫಿಸಿಸಾರ್ಪ್ಷನಲ್ಲಿ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸಸ್ ಆರ್ ವೀಕ್, ಹಂಗಾಗಿ ಡಿಸಾರ್ಪ್ಷನ್ ಶುರುವಾಗುತ್ತೆ. ಕೆಮಿಸಾರ್ಪ್ಷನಲ್ಲಿ ಬಾಂಡ್ಸ್ ಬ್ರೇಕ್ ಆಗೋದ್ರಿಂದ ಟೆಂಪ್ರೇಚರ್ ಜಾಸ್ತಿ ಆದಂಗೆಲ್ಲ ಅಡ್ಸಾರ್ಪ್ಷನ್ ರೇಟ್ಸ್ ಎಕ್ಸ್ಟೆಂಟ್ ಆಗಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಸ್ವಲ್ಪ ಹೊತ್ತು. ಅದಾದಮೇಲೆ ಅಗೈನ್ ಇಟ್ ಡಿಕ್ರೀಸಸ್ ಒನ್ಸ್ ಎ ಲೇಯರ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಈಸ್ ಕಂಪ್ಲೀಟೆಡ್. ಸೊ ದಿಸ್ ಇಸ್ ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಫಿಸಿಕಲ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆ್ಯಂಡ್ ಕೆಮಿಕಲ್ ಅಡ್ಸಾರ್ಪ್ಷನ್. ಅಂಡರ್ colloids, normally we come across three different types of solutions based on the particle dimension of the solute particles. Supposing if particle dimension is less than 1 nanometer in diameter, then it is called as crystalloid. Suppose if particle dimension is more than 1000 nanometer in diameter, then it is called as suspensionoid. Suppose if particle dimension of solute ranges between 1 and 1000 nanometer in diameter, then it is called as colloid. ನಮ್ಗೆ ಗೊತ್ತಾಯ್ತು ಇವಾಗ. colloids ಅಂದರೆ these are heterogeneous mixtures in which the particle dimension ranges between 1 to 1000 nanometer in diameters. Now colloidsನ ನಾವು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಮಾಡ್ತೀವಿ into two different types based on affinity between solute and solvent. One is called as lyophilic colloids, other one is lyophobic. Lyophilic colloids ಅಂದರೆ ಸಾಲ್ವೆಂಟ್ ಲವಿಂಗ್ colloids ಅಂತೇಳಿ. Lyophobic colloids andre solvent hating colloids. Lyophilic solvent loving. Solvent loving colloids. Whereas lyophobic solvent hating colloids. Solvent hating colloids. They don't like solvents. Lyophilic colloids are stable comparative to lyophobic colloids. These are less stable. Again, lyophilic colloids are reversible. Reversible. Whereas lyophobic colloids are irreversible. Irreversible. So lyophilic colloids are more stable. Lyophobic colloids are less stable. Lyophilic colloids are reversible. Lyophobic colloids are irreversible. Preparation of lyophilic salt is easy. You can just mix DP and DM, you get lyophilic salt. Preparation of lyophobic salt is not easy. Lyophilic colloids will have more viscosity when compared to lyophobic colloids. The surface tension of this also more when compared to this one. In this case, the surface tension viscosity almost equal to that of dispersion medium. ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರೇ, ಇವೆಲ್ಲವೂ ಕೂಡ ಡಿಫ್ರೆನ್ಸಸ್ ಬಿಟ್ವೀನ್ ಲಯೋಫಿಲಿಕ್ ಅಂಡ್ ಲಯೋಫೋಬಿಕ್ colloids. So lyophilic and lyophobic colloid na we can call by depending on type of solvent. Hydrophobic, hydrophilic if the solvent is water. Just like that, because based on the solvent we call hydrophilic, hydrophobic, solvent loving, solvent hating. Lyophilic colloids require more amount of electrolyte for coagulation, whereas lyophobic colloids require less amount of electrolyte for coagulation. So istu nimage gottidre idra mele you can concentrate, you get basic concept cleared. Ene question bandre idra mele answer madabodu neevu. Colloids are again classified into 8 different types based on the physical state of DP and DM. ನಮಗೆ 3 ಫಿಸಿಕಲ್ ಸ್ಟೇಟ್ ಗೊತ್ತಿದೆ, ನಮಗೆ ಗ್ಯಾಸ್, ಲಿಕ್ವಿಡ್ ಆ್ಯಂಡ್ ಸಾಲಿಡ್. ನೀವು ಕಾಂಬಿನೇಷನ್ ಮಾಡ್ತಾ ಹೋದರೆ ಯು ಗೆಟ್ 8 ಡಿಫರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ colloids. Gas in gas is not possible. Remember, colloid of gas in gas is not possible. So this is not possible. Apart from this, there are 8 different types of colloids. Gas in liquid, gas in solid, liquid in liquid, liquid in solid, liquid in gas, solid in solid, solid in liquid, solid in gas. So there are 8 different types of colloids. ಇದು ಮೇಲೆ ಕ್ವಶನ್ ಬರೋ ಚಾನ್ಸಸ್ ಇದೆ, ನೋಡ್ಕೋಬೇಕು. ಸೊ ಇಷ್ಟು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಫ್ colloids and basic concept about colloids. Dear students, these are the important properties of colloids. The first one is Tyndall effect. It is also called as an optical property of colloids. Colloids have ability of scattering a particular wavelength of visible light. For the same reason, the sky looks blue in color. So when you pass an intense beam of light through a solution of colloid, you can see the beam of light becoming brighter and brighter because of scattering of radiations of light. That is called as Tyndall effect. And the next is Brownian moment. You know that Robert Brown for the first time discovered that particles of colloid are in motion in zigzag pattern. That is called as Brownian motion. And electroporation, it's a process wherein we decide or we determine the charge present on colloidal particles. Dear students, ನಿಮ್ಗೆ ಗೊತ್ತಿರಲಿ, colloidal particle ಮೇಲೆ either they have negative charge or they have positive charge. The origin of charge on the particles of colloid is based on 2 factors. Number 1, it is due to the dissociation of surface groups. The second reason is that due to the preferential adsorption of cation or anion on the surface of colloidal particles. For example, ferric hydroxide salt is positive salt because of adsorption of ferric ions on the surface of particles of colloids. Exactly similarly, the gold salt is negative salt, that is because of adsorption of OH minus preferentially on the surface of colloidal gold. Exactly, arsenious sulfide salt is negative salt because of adsorption of S2 minus on the surface of arsenious sulfide salt particles or colloidal particles. So thereby we can say each and every colloidal particle is electrically charged. Now, the electrical charge, the type of electrical charge can be determined by a process called electrophoresis. In the presence of an applied electric field, depending on the charge on the colloidal particle, the particles of colloid can move either towards the positive electrode or negative electrode depending on the charge present on them. And the process is called as cataphoresis or electrophoresis. The next concept is hot spot in this particular chapter, surface chemistry. The first hot spot I told you, adsorption, type of adsorption, and the second hot spot in this chapter, surface chemistry, is coagulation or flocculation. Dear students, the flocculation and coagulation have a thin line difference. What is flocculation? What is coagulation? Put together, same concept it is. The aggregation of colloidal particles together to grow into bigger size molecules or particles is called coagulation. For both the process, flocculation and coagulation, you need to add electrolyte. So, if the concentration of electrolyte added is minimum, then the flocculation take place, nothing but similar to coagulation. Whereas, when the concentration of electrolyte added is higher concentration, then the coagulation take place. Then how this flocculation and coagulation are different? Flocculation is reversible, whereas coagulation is irreversible. Flocculation is reversible, on shaking you get back the colloid again. Adre coagulation admele you cannot get back the colloid again. That's a thin line difference between flocculation and coagulation. Flocculation is happening when the concentration of electrolyte added is minimum, and coagulation happening when the concentration of electrolyte has added is maximum. Higher concentration lead to coagulation, lower concentration of electrolyte lead to flocculation. Flocculation is reversible, whereas coagulation is irreversible. So, the minimum quantity of an electrolyte in millimoles per liter required to cause a coagulation of 1 liter of a colloidal solution is called as flocculation of that particular electrolyte. So, lower the flocculation value, higher is the coagulation capacity. So, flocculation value decides which electrolyte is best in coagulation. So, this is about the flocculation and coagulation. The next concept is protective colloids or protection of lyophobic colloids. You know that lyophobic colloids are unstable, whereas lyophilic colloids are stable. The stability of lyophobic colloid can be enhanced by addition of little amount of suitable lyophilic salt. The lyophilic colloid used for this purpose is called as protective colloid. So, this is referred or this is measured in terms of gold number value. The minimum quantity of lyophilic colloid required in milligrams to just prevent 10 gram of gold salt, the minimum quantity of lyophilic salt, that is dry lyophilic salt, required in milligrams to just prevent 10 ml of standard gold salt, even after adding 1 ml of 10% NaCl solution, is called as gold number, is also referred as Zsigmondy gold number. So, lower the gold number, greater the stabilizing property. So, the protective action inversely proportional to gold number. So, ಈ ಗೋಲ್ಡ್ ನಂಬರ್ ಮೇಲೆ ಕೂಡ ಭಾಳಷ್ಟು ಕ್ವಶನ್ಸ್ ಬರ್ತವೆ. ಕೋಗ್ಯುಲೇಷನ್ ಫ್ಲಕ್ಯುಲೇಷನ್ ಮೇಲೆ ಭಾಳಷ್ಟು ಕ್ವಶನ್ ಬರ್ತವೆ. Therefore, I told it's hot spot in this chapter. Dear students, so these are the important headings you have to concentrate. The first one is oxidation state. ನಿಮಗೆ ಗೊತ್ತಿರಲಿ D block elements exhibit variable oxidation state. The oxidation state ranges from +1 to even +8 also. The +1 is limited, only few elements, that is chromium and copper family elements, exhibit +1 oxidation state. That's a minimum oxidation state. So, +1 is the minimum, and these elements even can exhibit 0 oxidation state also in some compound. For example, nickel tetracarbonyl, nickel has 0 oxidation state. So, in general, the D block element exhibit variable oxidation state. The variable oxidation state of the D block element is because of the almost similar energy of Ns and N-1d orbitals. So, therefore, both Ns and N-1d electron take part in bonding. So, therefore, they exhibit variable oxidation state. So, group number 3, that is scandium family, usually exhibit only one oxidation state of +3, but they do exhibit even +2 also, but the stablest oxidation state is +3 for the group 3 element. Otherwise, almost all element except in group number 12 from group number 4 to group number 11 exhibit variable oxidation state. Remember, so these elements can exhibit even highest oxidation state of +8 in case of osmium tetroxide. Osmium has highest oxidation state of +8. In 3D series, the highest oxidation state is achieved by manganese, which is +7. The lowest oxidation state is achieved in case of chromium and copper family to attain extra stability, that is +1. So +1 generally exhibited by copper, which is to attain extra stability. So remember, these elements exhibit oxidation state from highest to the lowest also. Even sometimes they exhibit 0 oxidation state also. So this variable oxidation state helps these elements to behave as a catalyst, remember. The next most important property is color and magnetic property. This is also hot spot in this chapter. Most of the D block element compounds are colored, but some of the compounds which are not colored also. So the exhibition of color by the compounds of D block element is due to the presence of one or more unpaired electrons in D subshell. So those elements are those compounds in which the D block element have no unpaired electrons, then the compound is going to be colorless. I should have no color. So the compounds which are having D block element in which there is partially filled d orbital, in which there are unpaired electron, can exhibit color. Best example is copper. Copper in +2 oxidation state, it is in aqueous medium, it exhibits blue color. Whereas in +1 oxidation state, since it has no d unpaired electrons, there are no unpaired electrons in because D10 configuration. Therefore, copper +1 compounds are colorless, copper +2 compounds are generally blue in color in aqueous medium. Exactly same way, silver in +1 oxidation state colorless, scandium +3 oxidation state colorless, Au +1 oxidation state colorless, mercury +2 oxidation state colorless, titanium +4 oxidation state colorless, manganese +2, +3, +4 etc. will have a color, iron +2, +3 will have a color. So those elements which have unpaired electrons in their D block or in their valence shell can exhibit color. The color of these elements is because of splitting of d orbital into two sets of orbitals, say T2g orbitals and Eg orbitals in presence of anions or ligands is responsible for color of these compounds. While promotion of the electrons from T2g set of orbital to Eg orbital, one particular wavelength of the color of the particular white light will be absorbed by the compound and remainder color will be emitted. So therefore, the complementary color is absorbed by the compound. So therefore, most of the D block element compounds exhibit color. So the color of the compound depends on the type of color it's absorbed and the type of color it emitted. That means complementary color will be acquired by the compound. Next is magnetic property. So magnetic property is also attributed to this D block element or D block element compounds, the presence or absence of unpaired electrons. So those elements which are having no unpaired electrons will be diamagnetic in nature. Those elements which are having unpaired electrons will exhibit paramagnetism. Some of these elements like iron, cobalt, nickel can become even permanent magnets. That means these are used in making permanent magnet because of existence of more number of unpaired electrons. So more the number of unpaired electrons, more is the paramagnetic property. Generally magnetic property is referred in terms of mu. Mu is equal to square root of n into n plus 2. So mu is equal to square root of n into n plus 2. So where n is number of unpaired electrons, mu is equal to square root of n into n plus 2, where n is number of unpaired electrons. So more the number of unpaired electrons, more is the magnetic property. Dear students, so these are the basic concepts which are important in this chapter. Dear students, now let us see some model questions which comes under surface chemistry and DMDF block elements. The question is, rate of physics option increases with, there are 4 options given. ಅಂದರೆ physics option ನ ರೇಟ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ಯಾವಾಗ? ಆಪ್ಷನ್ ಎ ಡಿಕ್ರೀಸಸ್ ಇನ್ ಟೆಂಪರೇಚರ್, ಇನ್ಕ್ರೀಸ್ ಇನ್ ಟೆಂಪರೇಚರ್, ಡಿಕ್ರೀಸ್ ಇನ್ ಪ್ರೆಷರ್, ಡಿಕ್ರೀಸ್ ಇನ್ ಸರ್ಫೇಸ್ ಏರಿಯಾ. ನಿಮಗೆ ಗೊತ್ತಿದೆ, ದ physics ಆಪ್ಷನ್ ಡಿಪೆಂಡ್ಸ್ ಆನ್ ಟೆಂಪರೇಚರ್. ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ದಂಗೆಲ್ಲ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ವೀಕ್ ಆಗೋದ್ರಿಂದ ಡಿಸಾಪ್ಷನ್ ರೇಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಅಡ್ಸಾಪ್ಷನ್ ರೇಟ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ದಂಗೆಲ್ಲ ರೇಟ್ ಆಫ್ physics ಆಪ್ಷನ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಡಿಸಾಪ್ಷನ್ ರೇಟ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಅಡ್ಸಾಪ್ಷನ್ ರೇಟು ಕಡಿಮೆ ಆಗುತ್ತೆ. ಕೆಮಿಸ್ ಆಪ್ಷನಲ್ಲಿ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಮಾಡ್ದಂಗೆಲ್ಲ ಅಡ್ಸಾಪ್ಷನ್ ರೇಟ್ ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಸಣ್ಣ ಎಕ್ಸ್ಟೆಂಟ್, ಆಮೇಲೆ ಅಲ್ಲೂ ಕೂಡ ಕಡಿಮೆ ಆಗ್ತಾ ಬರುತ್ತೆ. ಸೊ ಬಿಕಾಸ್ ಕೆಮಿಸ್ ಆಪ್ಷನಲ್ಲಿ ಕೆಮಿಕಲ್ ಬಾಂಡ್ಸ್ ಇನ್ವಾಲ್ವ್ ಆಗಿರೋದ್ರಿಂದ ಬಿಟ್ವೀನ್ ಅಡ್ಸಾರ್ಬೇಟ್ ಆ್ಯಂಡ್ ಅಡ್ಸಾರ್ಬೆಂಟ್ ರೇಟ್ ಆಫ್ ಅಡ್ಸಾಪ್ಷನ್ ಇನ್ಕ್ರೀಸಸ್ ಇನ್ ಕೆಮಿಸ್ ಆಪ್ಷನ್. ಆದರೆ ಕೀಪ್ ಇನ್ ಮೈಂಡ್, physics ಆಪ್ಷನಲ್ಲಿ ರೇಟ್ ಆಫ್ ಅಡ್ಸಾಪ್ಷನ್ decreases with increase in temperature. As a increase in temperature weaken the intermolecular force of attraction between adsorbent and adsorbent, the rate of adsorption decreases. ಹಾಗಾದರೆ ಆಪ್ಷನ್ ಏನಿರಬೇಕು ಹಂಗಾದರೆ, is it decrease in temperature, increase in temperature, decrease in pressure, decrease in surface area? Obviously the decrease in temperature should be the right option. So the rate of physics option increases with decrease in temperature. The next question is, during the adsorption of a gas on the surface of a solid, which of the following is true? There are 4 options given. Delta G is less than 0, delta H greater than 0, delta S is less than 0, delta G greater than 0, delta H less than 0, delta S is less than 0. Option C, delta G less than 0, delta H less than 0, delta S less than 0, delta G less than 0, delta H less than 0, delta S greater than 0. ಈ ಕ್ವಶನ್ ಆನ್ಸರ್ ಮಾಡೋದಕ್ಕೆ ನಿಮಗೆ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಆಫ್ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಅರ್ಥ ಆಗಿರಬೇಕು. ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ ದ ಅಡ್ಸಾರ್ಬೇಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಡ್ಸಾರ್ಬೆಂಟ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಕೂತ್ಕೋಬೇಕಾದ್ರೆ ದ ಫ್ರೀಡಮ್ ಆಫ್ ಮೂಮೆಂಟ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಆಫ್ ಅಡ್ಸಾರ್ಬೇಟ್ ಡಿಕ್ರೀಸಸ್. ನಥಿಂಗ್ ಬಟ್ ಎಂಟ್ರೋಪಿ ಡಿಕ್ರೀಸಸ್, ರ್ಯಾಂಡಮ್ನೆಸ್ ಡಿಕ್ರೀಸಸ್, ಡಿಸಾರ್ಡರ್ ಡಿಕ್ರೀಸಸ್. ಸೊ ಡೆಲ್ಟಾ ಎಸ್ ಹ್ಯಾಸ್ ಟು ಬಿ ನೆಗೆಟಿವ್. ನಮಗೆ ಗೊತ್ತಿದೆ, adsorption of adsorbate molecule on surface of adsorbent involves liberation of heat. So the process of adsorption is exothermic. So delta H is negative. Freedom of molecular movement decreases, delta S is negative. Enthalpy change is negative and the process is spontaneous. Therefore delta G has to be negative. ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ, ಯಾವುದಾದ್ರು ಒಂದು ಪ್ರೋಸೆಸ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗಬೇಕು ಅಂದರೆ ದ ಡೆಲ್ಟಾ ಜಿ ವ್ಯಾಲ್ಯೂ ಮಸ್ಟ್ ಬಿ ನೆಗೆಟಿವ್. ಸೊ ಇನ್ ದಿಸ್ ಕೇಸ್ ದ ಡೆಲ್ಟಾ ಎಚ್ ವ್ಯಾಲ್ಯೂ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಟಿ ಡೆಲ್ಟಾ ಎಸ್ ಆ್ಯಂಡ್ ಡೆಲ್ಟಾ ಜಿ ಬಿಕಮ್ಸ್ ನೆಗೆಟಿವ್. ನೀವು ಡೆಲ್ಟಾ ಜಿ ಇಸ್ ಇಕ್ವಲ್ ಡೆಲ್ಟಾ ಎಚ್ ಮೈನಸ್ ಟಿ ಡೆಲ್ಟಾ ಎಸ್ ಈಕ್ವೇಷನ್ಗೆ ಇವೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಡೆಲ್ಟಾ ಜಿ ನೆಗೆಟಿವ್ ಬರಬೇಕು ಅಂದರೆ ಡೆಲ್ಟಾ ಎಚ್ ವ್ಯಾಲ್ಯೂ ಶುಡ್ ಬಿ ಗ್ರೇಟರ್ ದೆನ್ ಟಿ ಡೆಲ್ಟಾ ಎಸ್ ವ್ಯಾಲ್ಯೂ. Then only the adsorption process becomes spontaneous. ಸೊ ಅಲ್ಟಿಮೇಟ್ಲಿ ನಮಗೇನು ಗೊತ್ತಾಯಿತು, ಅಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೋಸೆಸ್ಸಲ್ಲಿ ಡೆಲ್ಟಾ ಎಚ್ ನೆಗೆಟಿವ್ ಅಂದರೆ ಎಕ್ಸೋಥರ್ಮಿಕ್, ಡೆಲ್ಟಾ ಎಸ್ ನೆಗೆಟಿವ್ randomness decreases and the process is spontaneous, that is delta G is negative. ಸೊ ಇಷ್ಟು ಆಪ್ಷನ್ಸಲ್ಲಿ ನೋಡ್ತಾ ಬಂದರೆ ಆಪ್ಷನ್ ಸಿ ಕರೆಕ್ಟು ಆಪ್ಷನ್. ಡೆಲ್ಟಾ ಜಿ ಲೆಸ್ ದೆನ್ 0 ಅಂದರೆ ಡೆಲ್ಟಾ ಜಿ ನೆಗೆಟಿವ್, ಡೆಲ್ಟಾ ಎಚ್ ಲೆಸ್ ದೆನ್ 0 ನೆಗೆಟಿವ್, ಡೆಲ್ಟಾ ಎಸ್ ಲೆಸ್ ದೆನ್ 0. ಸೊ ಫ್ರೀ ಎನರ್ಜಿ ಡಿಕ್ರೀಸಸ್, ಎಂಥಾಲ್ಪಿ ಡಿಕ್ರೀಸಸ್, ಎಂಟ್ರೋಪಿ ಆಲ್ಸೋ ಡಿಕ್ರೀಸಸ್. Delta G negative, delta H negative, delta S negative. So option C should be the correct option.